Okay, today I'm going to show how I go about modifying a post-war Lionel 1122 or 1122E non-derailing switch to run off of fixed voltage, and in this particular case we're going to go one step further on how to show how to power it off a capacitor. I've seen a lot of articles on the internet and a few pictures, but never a video. I have to give credit to Walt Rapp. He sent me a very helpful email with a few pictures, and he in turn credits Bob Nelson. As Walt said, he just wrote the article. Bob gave him all the technical details. I've got two switches here. This one on the left is the 1122E, the one on the right is the 1122. You can kind of tell the difference on the 1122, a little bit more square corner here. It's more rounded. Also the rails are a little bit different. The 1122E is a little bit more elegant design. The one on the right, I've already done the modification, at least to get the wire out from the solenoid, and I'm going to show how I go about doing it on this 1122E. Lionel actually has a very good video on their website that shows how to do this on a more, I'll say, modern switch. It's a little bit easier. As you'll see, there's a little bit of cutting you have to do on these older switches. The other thing, I guess, that the Lionel video doesn't show is how to hook up the capacitor, so I'm going to show you how to do that today too. Okay, here's parts that you're going to want to get to wire up your switch to work off of a capacitor. I got some 20 gauge stranded wire. You could use like a 18 or 16 gauge, but might be a little bit harder to work with. 22 gauge would probably be fine. I got the 20 gauge stranded, just that's what they had at the local hobby store. You also want to get some shrink tubing. I got two sizes, 1/16 inch and 3/32 inch. You'll see where I use that later. I use the 3/32 when I connect the capacitor to the resistor, and the 1/16 inch when I connect an extension wire to the solenoid wires off the switches. You don't have to use the shrink tubing, but I just feel that it helps give a little strength to that solder joint, and it's also a good idea to have it, especially off the solenoid wires coming off the switch, to help protect them, because they are pretty small wires. You're also going to need a diode, sometimes also referred to as a rectifier. It's basically converting the AC from your transformer into DC current going into the capacitor. I'm not sure the significance of the 1N4001. It seems like a common, I think that's actually maybe the Radio Shack model number, but you'll want to make sure it's rated for 50 volts and 1 amp, and you'll want an axial. That basically, you'll see all these are axials. You'll want to get axial on all these, because otherwise, like if you were to get one that's radial, you'd have both wires coming out of the bottom, and it's going to be harder to work with. The resistor, you'll want a 10 watt 100 ohm wire wound axial resistor. I have two here. This top one I got at Radio Shack, and then the bottom one I ordered online in bulk. You'll see here I also have the prices that I paid for these. So the diodes are dirt cheap. You could even find them cheaper. The resistors, I actually paid 41 cents each because I got 10 of these, so I kind of got the volume discount. And then the capacitor, you'll want to get a 4700 microfarad 35 volt axial capacitor. The manufacturers of these things, like I said, really doesn't matter. They're all very common electronic components. The sizing is very, very common. It's not like any of these are specialized. Where can you get them? I got my diodes and resistors from digikey.com, digikey.com, or another popular website is Mouser, MOUSER.com. You can also find these things on eBay, and on eBay a lot of the stuff, if you're willing to wait a couple weeks, you can get it from like Taiwan, and it is dirt cheap. I think I saw the diodes for like 9 cents each, and the resistors for maybe 25 cents each, and the capacitors for $1. And even with shipping, they still come in really cheap if you're willing to wait. You can also, I guess, go to, if you have one that's still in business, a local Radio Shack. You will pay a premium at Radio Shack. I think at Radio Shack the capacitors were like $4.50 each, and the diodes, a 2-pack, was probably $1.50, and I want to say 2-pack on the resistors at Radio Shack, they were at least $1.50 too. So just a matter of how quick you want them. Okay, here we got the cover off our 1122E switch. Oh, one thing I should state up front. This whole thing assumes the switch already works under normal track power. That's one thing you should verify ahead of time before you start work, so you don't go through this whole thing and then find out there's something else wrong with the switch. So there's a whole other series of articles and how-tos on how to fix switches, but we're starting off here with a switch that works. I generally take this opportunity to clean up the switch with some alcohol and whatnot, and lots of Q-tips and some pipe cleaner to get under the frog here. But so that's the first premise, that the switch does work. So I got the cover off. You'll see here, and you're probably not going to be able to see it on the video, but there's a wire right next to my thumb that's going on to the underside of the switch, and I've noticed on the 1122Es it's actually got a little bit of a covering over it, whereas the 1122s don't cover the 2 wires, one coming off of each solenoid. So you have to get to that wire, and to do that, on these older switches, you've got to you got a couple choices to make on how you're going to get to that wire. One way is you can drill out all the rivets, bend back the these little clips here on the rails, and take the whole backside of the switch off. I did that on an older switch and decided that really wasn't the way I wanted to go. It makes me a little nervous messing with these tabs here on the rails. And the switch it is 60 years old, so instead I chose to go the route where you take basically I used a Dremel tool to cut out a little square to access where the wires come through the bottom of the switch. This also provided me with a good excuse to buy a new tool, so I was able to get my Dremel. The dimensions here, these, just so you know, the 2 5/8 it's from the edge, the black edge, the outside edge of the switch, 7/8 from the bottom, 1 1/8 inch over, and then 1.5 inches deep. I found these dimensions, somebody else had measured them out on a picture on the internet. I think I changed mine by maybe 1/8 of an inch. Seemed to center a little bit better. The dimensions, though, are the same whether it's the 1122 or the 1122E switch. I just wanted to show you the Dremel I use. It's the Dremel 4000. I've got the thin cut blade with the easy lock fitting to cut it out. I'm not actually going to show you the video of me cutting it. Just I would recommend, if you have a Dremel, you use one with a little guard here, because it does throw out a lot of sparks, as I found. The other suggestion I have when you do this is go slow. Don't be in a hurry. There is a little bit of a gap between this the bottom plate on the switch and the plastic part on the top. But okay, so I did my cut, and the plate comes off, and I put a little arrow on there, so when I tape it back on later, I'll kind of know what the orientation is. And then you're going to find there's a piece of kind of like thick, rigid paper that you need to cut through. Actually, I kind of think on that side I kind of got it with the Dremel a little bit. Just get a good sharp X-Acto or a box cutter knife and just cut that out. So I'll do that next. Okay, and so now we've got our paper removed, and there is the zoom in here. So there is the wire we're looking for, and you'll see it's soldered right here, and this metal strip actually is in contact with the center rails on the other side of the switch. So right now this wire is getting its power from the track power, and what we're going to do, we're going to desolder this to free this wire. If you look, again, you're not going to be able to see it on this video, but the wire does actually go underneath that metal strip and wraps around and then is soldered on top. My soldering skills and desoldering skills have a lot to be desired, so I'm not going to show you that painful process. I will show you're better off watching some YouTube videos specific to soldering, but basically I use one of these little sucker things and then copper tape to desolder. I've found some of these go really easy. This is, I guess, about I think I've done about 6 of these so far. Some of them desolder really easy, and others I struggle with. So I'm going to go and get that solder off and free up that wire now. Oh, and in case you're wondering, this is what my soldering iron looks like. I think I got it on eBay for probably 10 or 15 bucks, and it came with the sucker and copper tape, a little bit of solder. I also use just like a kitchen copper scrub brush to keep the tip clean. So, okay, finally got that desoldered. That was, I'll admit, one of the tougher ones. It seems to me that I have a harder time with the 1122Es versus 1122s. Maybe they improve their soldering ability at Lionel between the two models. So there's the wire that we were desoldering from here. Again, remember it does go underneath and then wraps around on top, so you have to pull it out from underneath when you're desoldering. You'll see here there's a little protective wrap on the wire. You can actually see it on the other side of the switch. On your own switch, you really won't see it on the video, but I've noticed they added that on the 1122Es. On the 1122s, the earlier model, they didn't have that little protective wrap. But what we need to do now, that wire's kind of short, so we're going to solder another piece of wire onto it, a length of wire, so we have more to work with, and then we're going to drill a hole and pass it through the upper side of the switch so we can connect it to our new power source. You know, the length of wire here isn't magic. If you know exactly where on your layout your switch is going to go, you could measure out the exact length of wire you want. I'm still not sure where everything's going on mine, so I'm going to, I just cut about an 18-inch length, and then I'll join it to another wire later on when I get my layout figured out. Well, if you don't have one, you should get one of these. I'll say I borrowed this one from my dad. Great wire stripper. So there we go, twist that, and now, I'm not sure if you'll be able to see this too well, but I'm just gonna get these two twisted together and maybe give myself a little bit more length here to work with. Okay. And I'm just going to get these ready to solder together. Again, Like I said, I'm not going to bore you with my lack of soldering skills because they're not that great. Highly recommend you watch some other YouTube videos that are geared specifically toward soldering techniques, or good soldering techniques. I get by. So there we are, ready to solder it up. What I did, I just wrapped the thinner wire around the other one. Found that works best. So I'm going to solder this up and come back. I got soldered together fairly good. It's not pulling apart. Now the other thing I like to do here is, so on the parts list that I showed you, I like to put a little shrink tubing on here. Here's our 1/16 inch shrink tubing. I found the 1/16 fits around this 20 gauge wire nicely. Nice snug fit. And then as long as you're, well, actually I gotta measure it out here first before I start slipping it on. Okay, so that's good length. I find the 1/16 inch shrink tubing fits around the 20 gauge wire nicely, and as long as I haven't done too sloppy of a job on the soldered joint, find that it'll slip over my solder connection snugly too. Okay, here goes, let's see. Yeah, okay. Yeah. A little bit snugger than I'm accustomed to, but got it. Just tightening it up right up against the existing sheathing. A couple reasons you'll want to do this. First off, I think it helps give the solder joint a little more strength. Also, when you're passing the wire through the hole we're going to drill in here, it gives the wire some protection. You'll notice the wires coming off that solenoid are pretty thin, so you don't want to mess it up. I wouldn't want to have to try and replace one of these solenoids on these switches. Also, you know, the other thing, well, we'll get to that later on whether or not you have to pass the wire through the switch or can just continue run it off to the side. But next thing you need to do is shrink the shrink tubing. And you can watch some YouTube videos on how to do that. There's kind of three choices. You can buy, if you're into electronics, you might already have one. I guess we call it a heat gun, made specifically for shrinking this tubing. Since I only need to do a limited number of these switches, I really didn't want to spend 30 or 40 bucks for one of those. I've seen people try and use hair dryers. That seems kind of tough because most hair dryers don't quite, they do it, but it takes them several minutes to get enough heat out of that hair dryer. Or you can go with the lighter approach. Might want to practice this on some scrap wire before you do it, but I've done it a few times, so this doesn't take long. And you know, you can come back if you... Now, you could just, you know, if you knew exactly where your layout was going to go, I guess you could drill a hole and pass this through the underside of your layout. I'm not that good. The other thing you might consider is just passing the wire out the side of the switch like that. I would be worried about pinching the wire though. So what I'm going to do is drill a hole close to where the wire is. And it's going to probably, the hole is going to end up coming out right around in here. First you got to locate where you want to drill your hole. Get out of the shadow. If you look on your switch, and again, I don't think you'll be able to see this on the video, but I can see right there is where the wire passes through the bottom of the switch. So I want to drill my hole kind of in line with that. And what I learned first time I did this is you don't want to drill the hole right up next to the housing there for the solenoid, because when you do, your switch cover will block your hole that you drill. So, and I think I use what size bit do I use to do this? Yeah, 7/64 works just fine. So what I'm going to do is I take a look here, and I kind of gauge off of the holes here on the switch where I need to drill my hole, where everything lines up. So it looks like I'm lining up with this hole right here, so I'm going to drill right in line with that hole just a little bit. So okay, now we got our hole. Look, and there's the hole we just drilled. A little bit off where I would have expected, but close enough. So now we're just going to pass the wire through here. And this is where it's nice to have that shrink tubing, because then you don't have to worry about your wire, your solder joint rubbing up against that hole. Okay, there we go. And we have our wire coming through this side of the switch. Okay, now that's all done. I can button this back up. We'll get our paper back on there, and you know, the paper, like I said before, you want a pretty sharp knife. It is kind of thick, thicker than the average copier paper. Maybe not quite as thick as construction paper, but actually, I'm going to make, yeah, that thing's pulled through nicely. So, and I just use some electrical tape, and one more will do it. Okay. So now, we got our wire coming off our switch here. Next thing I like to do before I start hooking up the capacitor is to test the switch off of fixed voltage to make sure that in between desoldering and soldering it and passing it up through this hole and everything, that I didn't somehow muck up the wires and you know, break one of the wires or something. So I'm gonna set this, wire this up, and we're gonna test it to make sure that everything still works. Okay, so now we got our switch wired up here. I'm using a Lionel KW transformer. Here's our wire coming off the switch that we just soldered up. It's going to the D terminal on this transformer. It's the 20 volt constant voltage output, and then over here I just got a little lock-on little section of track connected to the outside rail going to the common U terminal. So now we're going to test our switch. I'm just going to use a wire to do it rather than hook up the controller. So there we go. Switch throws nicely. And so now we know we didn't screw this up. We didn't mess up our solenoid. Now at this point, you know, I basically have done everything that you know, Lionel shows in their video for hooking up to fixed voltage. You could stop here and be done with it. The problem you can encounter though on these non-derailing switches is if you do park a train on the switch, with the fixed voltage hooked up the way it is, the solenoid will keep firing. And let's see if we can hear that. So if your train was parked on the switch, it would keep trying to throw the switch even though it's already thrown, and if you didn't catch it, you would burn out your solenoid. Hence, that's why people have set up these, what they call the capacitive discharge circuit, and that's what we're going to do next. Like I said, I'm not going to bore you with my lack of soldering skills, but here I have it all wired up. I've also tried and draw a picture because it might be a little hard in the video to follow where all the wires are coming and going from. But we'll just kind of start the beginning. Right here I'm connected to the again kW transformer, connected to the D terminal, which is the 20 volt fixed voltage on it. Coming out of there, there's my wire going along here. So basically on the picture, we're here going into the diode right here. The diodes are directional, and they'll be, and you're not going to be able to see it on the video, but when you get the diode, you'll see there's a little line on the diode. You want that line, and I kind of tried to represent it here on the picture. You want that line away from the transformer and towards the resistor. I've connected these into a terminal strip. You don't have to do this. I could have soldered the diode directly to the resistor, but when I do my setup, what I intend to do is I'm going to electrically connect all these individual posts on the terminal strip together, so I can feed all these over here off of the one diode. That's the other thing, you don't need a separate diode for each switch. You could conceivably power your entire layout from one diode, which is what I intend to do. You might use more just depending how you got your layout set up or for organization, but that's your choice. So basically this diode here is now connected to the resistor. So we're right here on the picture. We're coming into the capacitor. Oh, the other thing too, the resistors are not directional, so they can go either way. We're then coming into the capacitor. The capacitors, like the diode, are directional, and you'll see there'll be little arrows on the capacitor. And the output, the other end of that capacitor, is then going back to the common, or the U terminal on the transformer. Between the resistor and the capacitor, and this is a fun joint to solder because you gotta solder three things together at once. And I also put a little bit of shrink tubing on there too. When I soldered the capacitor, the resistor, and my wire coming off of there together, be sure to put the shrink wrap on either the capacitor or the resistor side before you do this. Otherwise you can't get the shrink tubing on there. Lesson learned. So anyway, this wire on here is coming off of here, and it is going back to our wire on our switch that ties back to the solenoid, and that's what this wire here is doing. These two wires are the same. So now I've got my transformer plugged in, and now we're going to throw the switch using the the capacitor is the power source. Okay, that should do it. So now, here we go. Now, you have to wait about 2 to 3 seconds for that capacitor to recharge before you can throw the switch again. There we go. So now, I'm going to wait. And this is all coming off the capacitor. That is the only thing that this solenoid is connected to electrically as far as the power source goes. Now, what I'm going to do here, I'm going to throw the switch and then I'm going to immediately try and throw it back again so you can see that the capacitor hasn't fully recharged yet. See there, it barely threw because the capacitor didn't have enough time to charge up. So now I'm going to wait. 1, 2, 3. There we go. And see there, I didn't let the capacitor recharge, so it didn't throw again. So now it's been a few seconds, and it does throw. And in case you can't see the picture from the angle, here's my little setup. Maybe do it. You could also conceivably power all your switches off a single capacitor, but keep in mind you'd have to wait 2 to 3 seconds between switch throws if you did it that way. Also, with as cheap as these parts are, I don't see any reason why you shouldn't put a single capacitor on each switch. Oh, the other thing, keep in mind the capacitor does store energy, so and I am unplugging the transformer. So the transformer is unplugged. There's still juice in that capacitor, so even though, and just to show you, I'm going to even disconnect here so you know there's no power coming off of this transformer. And because there's still energy left in that capacitor, the switch will throw. And usually get one throw. I don't think it's going to go again. Yeah. So just kind of keep that in mind when you're playing with these things, that that switch will throw one more time. I think that's about all that I can say on this. Yeah, you know, the other thing you could do, depending on how your layout is, how big of it is, you could run a wire around the entire underside of your layout, and you know, kind of use it as a bus wire for feeding for these, so you're not running everything back to your switch. That just all depends on what you want to do there. So there you go. That's my method on how to do it. Just realized I forgot to mention a couple things. The shrink tubing on here, on this triple connection between the capacitor, resistor, and your other wire going back to the switch, I used a 3/32 inch shrink tubing. And then the wire coming off the switch, I think you'll see what most people do, rather than just put the cover back on, is they'll usually pass the wire through these holes on the top of the switch, like that, like so, and then just run out the back of the switch, and then down into your track, or down into your layout, wherever it needs to feed through. And you know, I guess the other thing too is you probably want to use a black wire, then it'll tend to blend in with the switch itself, won't be so obvious. So that was just one other thing I wanted to add. Thanks.